Hello students, this video is about the inverse method techniques for solving three equations and three unknowns. Let's we have example of this three I have taken from help note. We have three equations. They are linear equations. If you see the powers here, everywhere power 1, and x1, x2, x3, they are labels. Sometime you will also find in lower classes teacher used to write x here, y, and then z. But we can come across matrices or the system with 4 variable, 5 variable. In that scenario, 1, 2, 3 will be the best option. Let's convert them into the matrix first. So the left side and the right side, two matrices are produced. Now the left side is the multiplication of two matrices. You see, if we multiply, we get that matrix. 1 into x, x1, then minus 2 into x2, so plus minus 2x2, and similarly 1 and to x3, it comes x3. The same we do for this row, for this row. So it means we can also write this way. Then we name them by matrix A, X and B. X usually we use for unknown, so x1, x2, x3 matrix. The order of this is 3 by 3. This one is 1, 3 and 1, 3 again. So we should consider their order. Oops, my god. Sometime to write with fingers it becomes headache. Okay, so 3 by 3 matrix. Then if we look at this one is A, then X and B, so its natural order becomes this. Now we are looking for X because X has got x1, x2 and x3, so A will be shifted to this side or multiplied both the side by A inverse. Now after that we go for determinant. We have explained Cramer rule, so that technique will be, I think, useful for you if you are not going to more detail of the matrices and determinants. And now we are ready for A inverse, which is 1 by A determinant is giant of A. Now a giant of a matrix with order 3 or more than order 3 by 3, it's not easy. Here we calculate cofactors. Cofactor 1, 1, 1, 2, because this is first row. Look, first row, so 1, 1 and 1. Then first column, second column and third column. Okay, similarly for second row, for third row. And note that there is one small t sitting on it. It means transpose, which is also when we convert this row into a column. Similarly, this row is converted into second column, and third row will be converted into third column. So when we take transpose, the rows come this way. Okay. Now what are cofactors? In this case, for cofactor detail you can go to book, but in this example, first of all, I'm doing this cofactor. So I write C11 minus 1 power 1 plus 1 because it is 1 1, and then if I change the color of my pen, oh my god, how to change it? Okay, so if we remove this column and this row, oops, I should go to the matrix, not here. Okay, because we are doing this from the matrix. Look, this is 1 1 position, so we delete this row and this column, and we will be left with, see, 1 minus 1, then minus 1 and 2. We multiply 1 with 2 and minus 1 with 1, so it comes 2 ones are 2. Then by definition of determinant minus comes, and minus 1 multiply minus 1 is 1, so our answer is 1. And minus 1 power, if you write this in bracket, so it comes minus 1 power 2, which means plus, so plus 1 is coming. 1 2, so again let's change color. Okay, let's take so 1 2 is actually this element, so this time we delete this row and this column. This you are doing to matrix A. 1 2, so 1 2 will be added in the power of minus 1, and you see 2 3 minus 1 and 2 will be left. Which are they? Equal minus 1 power 3, because 1 plus 2 3, multiply 2 with 2 4, minus 1 multiply 3 comes minus 3 again. So in next step it will become minus and 2 4 plus 3, which gives this minus 7. The same way we finish this procedure for all the elements of A. So this is 1 3 1 3 and 1 3 element is this one. We delete this row and this column, we will be left with 2 3 1 minus 1 and then calculation. Okay, let's make it clean. Okay, now for 2 1, so 2 1 is this element, we delete this row and this column, so see, minus 2 1 minus 1, and after calculation it comes 3 2 2 is this one, so we delete this row and this column, we will be left with 1 1 3 and 2, which is this one, and then multiply this way, there will be minus between them, and after calculation then 2 3 2 3 is here, so this row and this column will be deleted, we will be left with 1 minus 2, look, 1 minus 2, and here 3 and minus 1. After calculation this cofactor will come. The same way we do for third column. If I clean, so this is third column, this position is 3 1, this position is -1, and this position is 2. Okay, so if you delete this row and this column, you'll be left with -2 1 1 -1, which is this, and after calculation this will answer. Then sec this column and this row, so we will be left with 1 2 1 -1 and this. So all the cofactors have come out. Now we put this value on C11, C21, C31. So cofactor matrix will come. C11 value is -1, you see. C12 value is -7. C13 value is -5. This is C13. So I will write here -5. C21, which is here, its value is 3. C22 value is -1. Then C23, this one comes -5, and 3 1, this one is 1, then 3, and then 5. So this is cofactor matrix. Now we will multiply this with 1 by a determinant. I have written matrix for myself here. Okay, plug in value. So we just constituted this matrix. Now definition of A inverse, putting value of A determinant, which was coming 10 in the beginning. I didn't solve it, I left for you, and a joint with 3 by 3 or more new concepts, so I did it. This one, a joint. Now we are ready for x. So by definition, x equals A inverse times B. Plug in values. We multiply this 3 by 3 matrix with this 1 by 3 matrix. 1 multiply 3, then plus 3 multiply 5, then 1 multiply with 12. We multiply first row, so we get first row. Now second row, -7 is multiplied with 3, -1 is multiplied with 5, and 3 is multiplied with 12. Then we'll move to third one. So -5 and 5 will be multiplied with 3, 5, and 12, which comes this. After simplification, we get 3 from the first element, 1 from the second, and third from the third contents.